Hello students, welcome to our live APS classes, and as all we know that this is our foundation course especially for the students from 9 to 12. And in our today's live lecture, we will continue our quick revision for class 10th, and these are the short notes for term 1 exam that is to be held in November 2021. And our today's chapter for the quick revision is carbon and its compounds. So let us start with our chapter, that is the carbon and its compounds. So first of all, welcome to all the students who join with us our live APS classes. So dear students, our first topic regarding the chapter, that is the carbon and its compounds, is carbon and its compounds. What do you mean by the term carbon, and what are the various compounds that are related with the carbon? So two or more elements combine to form a compound. When two or more elements combine, after that they form the compound. Two or more elements combine to form the compound. So this is the compound when two or more elements combine with each other. After that they form the compound. There are two types of the compounds. One is the organic compound and the second one is inorganic compound. That means inorganic compound. That means compounds are divided into two types. One is the organic compound and the second one is inorganic compound. So organic compounds are those which are made up of carbon and hydrogen. Organic compounds are made up of hydrogen and carbon. So these are the organic compound. The compounds which are made up of carbon and hydrogen, these are known as the organic compounds. Next topic is covalent bond. What do you mean by the term covalent bond? And the first topic is carbon and its compound. When two or more elements combine to form a compound, and there are two types of the compounds. One is the organic compound and the second one is the inorganic compound. Organic compounds are those compounds which are made up of carbon and hydrogen. After that, the main important topic is covalent bond. What do you mean by the term covalent bond? The bond formed by sharing pair of electrons. The bonds which are formed by the sharing pair of electrons. The bonds which are formed by the sharing pairs of electrons. And these sharing pair of electrons that are between the two atoms. Are known as covalent bond. So here the covalent bonds are the bonds which are formed by the sharing of electrons between the two atoms. They are known as covalent bond. Carbon forms covalent bond. Carbon is the only compound which forms the covalent bond. So here carbon is the only compound which forms the covalent bonds. Carbon always exists in two forms. One is the free state and the second one is the combined state. That means carbon always exists in the two forms or the two states. One is the free state and the second one is the combined state. So free state of the carbon or free form of carbon is found in the form of graphite, diamond. These are the free forms of carbon, and fullerenes. So these are the free states of the carbon. That is the diamond, graphite and fullerenes. These are the free forms of the carbon, or these exist in the free state. Whereas in the combined state, carbon exists as carbon dioxide, glucose and sugar. So here beta, the bonds which are formed by the sharing pair of electrons between the two atoms, they are known as covalent bond, and carbon always exists, or carbon always forms a covalent bond. Carbon exists in the two forms. One is the free state and the second one is the combined state. Free forms of the carbon are found as a graphite, diamond and fullerenes. And in the combined state, carbon exists as carbon dioxide, glucose and sugar, etc. Next, what are the allotropes of carbon? So different forms of the elements that have same chemical properties but different physical properties are known as allotropes. So allotropes are the different forms of an element that has same chemical properties but different physical properties. They are known as allotropes. Allotropes. So there are three allotropes of the carbon. One is the diamond, second one is the graphite, and the third one is the fullerene. So these are the three allotropes of the carbon. One is the diamond, second one is the graphite, and the third one is the fullerene. So first of all, we will take the diamond, that is the allotropic form of carbon. Diamond exists as a three-dimensional network. Diamond exists as a three-dimensional network. Three-dimensional network. Diamond exists as a three-dimensional network with strong carbon-carbon covalent bonds. So these diamond exist as the three-dimensional network with strong carbon-carbon covalent bond. Carbon-carbon covalent bond. So here diamond, it always exists as a three-dimensional network with strong carbon-carbon covalent bonds. Diamond is always hard in nature. It is hard in nature. Diamond always exists as a hard form of nature with high melting point. With high melting point. It shines in the presence of light, and diamond always shines in the presence of sunlight or light. Shines in the presence of light. In the presence of light. And it is a bad conductor of electricity. The most common use of diamond is use of the diamond is in jewelry, and it is also used in cutting and drilling tools. So this is the first allotropic form of the carbon, that is the diamond. And diamond, it exists as a three-dimensional network with strong with strong covalent bonds. And diamond, it is always hard in nature with high melting points, and it shines in the presence of light, and it is a bad conductor of electricity. And the most common use of the diamond, that is used in the jewelry, and it is also used in cutting and drilling tools. Second allotropic form of carbon is the graphite. Graphite is made up of weak van der Waals forces. It is always made up of weak van der Waals forces. Van der Waals forces. Each carbon atom is bonded with other three carbon atoms. Each carbon atom is bonded with three other carbon atoms in order to form the hexagonal rings. Hexagonal rings. That means each carbon atom is bonded with other three carbon atoms in order to form the hexagonal rings. And it serves as a good conductor of heat and electricity. Serves as a good conductor of heat and electricity. Good conductor of heat and electricity. It is used as a dry lubricant for machine parts, as well as it is used in the lead pencils. So graphite, it is always used as a dry lubricant, especially for the machine parts, as well as it is used in the lead pencils. The third allotropic form of carbon is the fullerenes. It is a hollow cage which exists in the form of spheres, and its structure is similar to that of the fullerene. But along with hexagonal rings, sometimes it forms the pentagonal or heptagonal hexagonal. Rings are also present. So this is the structure of the fullerene, and the structure of fullerene is just like this is the structure of fullerene. So this is the structure of fullerene. This is the structure of fullerene. Next, two important properties of the carbon. That means there are especially two important properties that are directly related with the carbon. And what are these two important properties of the carbon? And these two important properties of the carbon is, one is the catenation, and the second property is the tetravalency. So these are the two important properties of the carbon. One is the catenation and the second one is the tetravalency. Catenation is the self-linking property of the carbon. So catenation and tetravalency are the two major important properties of the carbon. Catenation is a property of the carbon by which carbon atoms can link one another by a covalent bond and can form long chains. That means catenation is the self-linking property of the carbon. That means carbon atoms can join with each other with the help of a covalent bond, and after that they forms a long chain. That means these chains are in the form of closed chain, and the second one is the branched chain, etc. So this is the catenation. Carbon atoms can link by a single bond, double bond, or triple bond. Carbon can link by single bond, carbon can link by double bond, carbon can link by triple bond. That means carbon atoms can join with each other with the help of a single bond, double bond, and triple bond. Okay? And carbon has always the valency of 4. Carbon has a valency of 4. And due to this valency, it is known as the tetravalency. Due to this property that carbon has a valency of 4, and on the behalf of that property, it is known as tetravalency. And due to this, one carbon atom can bond with other 4 carbon atoms. That means on the behalf of this property, one carbon atom can bond with the other 4 carbon atoms with other atoms such as oxygen, nitrogen, etc. So this is the important, so these are the two important properties of the carbon. One is the catenation and the second one is the tetravalency. Next important topic is hydrocarbons. What do you mean by the term hydrocarbons? So compounds which are made up of hydrogen and carbon, made up of carbon and hydrogen. So the compounds which are made up of carbon and hydrogen, they are known as hydrocarbons. There are two types of the hydrocarbons. One is the saturated hydrocarbons, and the second one is the unsaturated hydrocarbons. That means there are two types of the hydrocarbons. One is the saturated hydrocarbon and the second one is unsaturated hydrocarbons. Saturated hydrocarbons always consists of single bond. Whereas unsaturated hydrocarbons, they consist of double bond and triple bond. For example, Saturated hydrocarbons are alkanes because alkanes always consist of single bond. Whereas unsaturated hydrocarbons are alkanes, they have the general formula that is CnH2n plus 2. This is the general formula of the saturated hydrocarbons, and alkanes are the saturated hydrocarbons having the general formula that is CnH2n plus 2. Next is unsaturated hydrocarbons are the one which consists of double bond and triple bond. Double bond and triple bonds between the carbon atom. So these are the unsaturated hydrocarbons. For example, alkenes and alkynes. Alkenes and alkynes, they are represented the unsaturated hydrocarbons, and these have the general formula that is CnH2n minus 2. This is the general formula of the alkyne, CnH2n minus 2. This is the general formula of alkynes. Whereas CnH2n, this is the general formula of alkenes. This is the general formula of alkenes. Some saturated hydrocarbons and unsaturated hydrocarbons are represented here. First is CH4, that is methane. Second one is C2H6, that is ethane. C3H8, that is propane. C4H8, that is butane. C5H12, that is pentane. C6H14, that is hexane. C7H16, that is heptane. C8H18, that is octane. C9H20, that is nonane, and C10H22, that is decane. So these are some important hydrocarbons, some important saturated hydrocarbons and unsaturated hydrocarbons. Okay, that starts from methane and ends up to decane. So these are some important saturated as well as unsaturated hydrocarbons. Next is some important unsaturated hydrocarbons. One is ethene, CH2 double bond CH2, that is C2H4. This is ethene. Second one is propene. Formula is C3H6. Next is C4H8, that is 1-butene, and the formula is CH2 CH2 CH3. This is 1-butene. Next is 1, 2, 3, 4, 5. CH2 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 CH3, that is 1-pentene. Next is C6H12, that is 1-hexene. C7H14, that is 1-heptene. C8H16, that is 1-octane. 1-octane. So these are some unsaturated hydrocarbons. So structure of hydrocarbons can be represented in the form of electron dot structure as well as open structures. That means the structure of hydrocarbons can also be represented with the help of electron dot structures as well as open chain structures. For example, electron dot structure, electron dot structure, and open chain, open structure of ethane. Open structure of ethane. Open structure of ethane. Open structure of ethane. This is the open structure of ethane. For example, C. So this is the open structure or electron dot structure for the ethane. Next is electron dot structure and open structure of ethyne. Electron dot structure of and open chain structure of ethyne. Electron dot structure and open chain structure of ethyne, that is HC triple bond C bond H. Next is carbon compounds based on the basis of structure. Carbon compounds based on the basis of structures. That means carbon compounds can be classified as straight. Carbon compounds can be classified as straight chain compounds. Carbon compounds can be classified as straight chain compounds, branched chain compounds, branched chain compounds, and cyclic compounds. And cyclic compounds. So here carbon compounds can be represented or classified as straight chain compounds, branched chain compounds, and cyclic compounds, and these are represented as. So this is the straight chain compound, straight chain carbon compound. This is the structure of the straight chain carbon compound. This is the structure of the straight chain carbon compound. Next is branched chain compound. Branched chain compound. This is cyclohexane. Cyclohexane. Alternate positions for double bond, that is benzene. This is the branched chain compound. This is pyridine. This is pyridine. And these are cyclic compounds. These are the cyclic carbon compounds. Carbon compounds. And branching. This is branching. This is the structure of branched chain compounds. Next is functional groups. What do you mean by the term functional groups? One of the hydrogen atom functional groups. So one of the hydrogen atoms in hydrocarbons can be replaced by other atoms according to their valencies. That means in the functional groups, one of the hydrogen atoms in the hydrogen atom can be replaced by the other atom according to their valencies. The atoms which decides the properties of the carbon atoms. That means the atoms, those atoms which can decide the properties of the carbon atoms, they are known as the functional groups. For example, chlorine, bromine, alcoholic, aldehyde, ketones, aldehydes, ketones, and carboxylic acids. So these are the functional groups. Next is homologous series. So series of the compounds in which same functional group substitute for the hydrogen atom in a chain of the carbon. So this is homologous series, this is the general formula, this is the functional group, and these are the examples. Suppose the homologous series, example is alkanes, and the general formula of alkanes is CnH2n plus 2. Functional group and examples. The examples of alkanes are methane. Formula of methane is CH4. Ethane. The formula of ethane is C2H6. Example of alkane is propane, and the formula of propane is C3H8. Example of alkane is butane, and the formula of butane is C4H10. Next homologous series is alkenes. General formula is CnH2n. Functional group is carbon-carbon double bond, carbon single bond. Examples of alkenes are ethene, C2H4, propene. Formula of propene is C3H6, butene. These are the examples of the alkenes, that is C4H8. Next homologous series is alcohols. Formula of alcohols is CnH2n plus 1 OH. Functional group is OH. Examples are methanol, and the formula of methanol is CH3OH. Ethanol. Formula of ethanol is C2H5OH. Propanol. Formula of propanol is C3H7OH. Next is butanol, and the formula of butanol is C4H9OH. These are the homologous series: alkanes, alkenes, alcohols. Next is carboxylic acids. General formula of carboxylic acid is CnH2n plus 1 COOH. Functional group is COOH. Examples of carboxylic acid is methanoic acid. Formula is HCOOH. Ethanoic acid, and the formula is CH3COOH. Propanoic acid. Formula of propanoic acid is C2H5COOH. So these are the examples of the homologous series, their general formula, what are the functional groups of the various homologous series such as alkanes, alkenes, alcohols, and carboxylic acids, and what are the various examples of the alkanes, alkenes, alcohols, as well as carboxylic acids. Next is nomenclature of the carbon compounds. First of all, identify the number of carbon atoms in a compound. It is the first priority to identify the number of carbon atoms in the compounds and identify the longest chain. Second important rule for the nomenclature of the carbon compound is the functional group can be indicated by the suffix or the prefix. This is the most important criteria for the nomenclature of the carbon compounds, that is the functional group can be indicated either by suffix or the prefix. Third important rule is cyclic hydrocarbon is designated as prefix cyclo. Is designated as the prefix cyclo. If there are two or more different substituents, they are listed in alphabetical order. If the same substituents occurs more than once, if the substituents occurs more than once, then the location of each point on which the substituents occur is given. Suppose this is these are the different functional groups. First functional group is group's name is alkane. Suffix is ane, and the functional group, that is carbon hydrogen atoms. Second functional group name is alcohol. Suffix is ol and the functional group is OH. Next functional group name is alkene. Suffix is ene and the functional group C double bond C. Next functional group is alkyne. Suffix is ine and the functional group is C triple bond C. Next functional group name is aldehyde. Suffix is al and functional group is C double bond OH, that is CHO. Amine. Suffix is amine and the functional group is N. Next is ether. Suffix is ether and functional group is O. Ester, that is suffix is OH and the functional group is C double bond O, that is COO. Ketone, one and the functional group is C double bond O. Last one is nitrile. Suffix is I and the functional group is C triple bond N. So these are the different functional groups, their suffix ending and the functional group structure. Next is chemical properties of the carbon compounds. First important chemical property of the carbon compound is combustion. Carbon along with its compound is used as a fuel and it burns in the presence of oxygen to release a large amount of energy. Saturated hydrocarbons produce blue and non-shooty flame, whereas unsaturated hydrocarbons produced yellow shooty flame. Yellow shooty flame. Yellow sooty flame produce unsaturated hydrocarbons, whereas blue sooty flame is produced by saturated hydrocarbons. So combustion is the property where carbon along with its compounds used as a fuel and it burns in the presence of oxygen to release energy. Saturated hydrocarbons produce blue shooty flame, whereas unsaturated hydrocarbons that produce the yellow shooty flame. This is methane plus 2 molecules of oxygen, carbon dioxide plus water molecules is released. Next is oxidation. Alcohols can be oxidized to aldehydes, whereas aldehydes in turn can be oxidized to carboxylic acids. Oxidizing agents such as potassium permanganate, that is KMnO4, can be used as a oxidation. It can be used as a oxidation. This is the alcohol. 2, 4, 6, 8 aldehydes. This is alcohol. This is aldehyde. This is carboxylic acid. This is carboxylic acid. Next is addition reactions. Addition reactions, hydrogenation of vegetable oils is an example of the addition reaction. The most important example of the addition reaction is the hydrogenation of the vegetable oils. Addition of hydrogen in the presence of catalysts such as nickel and platinum. This converts into ghee. This converts into ghee. Examples are, this is the example of ethylene. This is the example of ethylene plus addition of bromine, that is Br2, in the presence of nickel and platinum. After that, it forms C. This is bromine. And after that, there is a formation of the addition reaction, and the result comes out to be 1,2, that is 1,2-dibromo, 1,2-dibromo ethane, and this is colorless. So this is the example of the addition reaction. Next is substitution reaction. When one atom in hydrogen is replaced by chlorine, bromine, iodine, etc., this is known as substitution reaction. That means when one atom in the hydrocarbon is replaced by the chlorine, fluorine, bromine, as well as iodine, it is known as substitution reaction. Good evening, Abhunika Bita, and this is your quick revision for your term 1 examination that is to be held in November 2021, and this is the short term revision for your science subject, and the chapter is carbon and its compounds. When one atom in hydrogen is replaced by chlorine, bromine, etc., this is known as substitution reaction. Suppose this is your methane. When methane is attached with chlorine in the presence of a light, that means one substitution or one hydrocarbon is replaced by chlorine, one hydrocarbon. That means there are 4 hydrocarbons, 4 hydrogens, and here one hydrocarbon is replaced with the chlorine, fluorine, bromine, and iodine. That is Cl plus HCl. This is your chloromethane. This is your chloromethane. Next is important carbon compounds, that are ethanol and ethanoic acid. These are the important carbon compounds, ethanol and ethanoic acid. These are the important carbon compounds. One is the ethanol and the second one is ethanoic acid. So ethanol is volatile liquid. It is a volatile liquid. Ethanol is a volatile liquid having low melting point. And it reacts with sodium. ओके बेटे, नहीं आएगा, पर ये है कि ये आपके लिए रिवीजन है, कोई ऐसी बात नहीं है, आप नेक्स्ट टर्म के लिए इसको प्रिपेयर करें, कोई ऐसी बात नहीं है, ठीक है ना बेटे. लो मेल्टिंग पॉइंट, ठीक है, एंड इट रिएक्ट्स विद सोडियम टू फॉर्म सोडियम एथॉक्साइड, and it reacts with sodium to form sodium ethoxide. The reaction is 2 molecules of sodium plus ethanol. It reacts with, this is your quick revision for your next exam beta, don't worry. And this is the result of sodium ethoxide. Sodium ethoxide. So this above reaction is used to test the presence of ethanol by the evolution of the hydrogen gas. So this above reaction, and it is used specially to test the presence of ethanol, especially by the evolution of the hydrogen gas. Next is dehydration of ethanol in the presence of hot sulfuric acid forms the alkenes. Reaction is, this is ethanol in the presence of hot concentrated sulfuric acid, it forms ethene with the release of water. Ethanoic acid is colorless liquid. When pure ethanoic acid freezes like ice, It is known as glacial acetic acid. When pure ethanoic acid freezes like ice, it is known as glacial acetic acid. Okay, beta, tomorrow is your science exam. Glacial acetic acid. It is formed at a temperature of about 16.6 degree centigrade. So ethanoic acid, acetic acid, when reacts with ethanol, it forms an ester. So ester can be identified by its sweet smell. For example, the reaction is, that is your ethanoic acid. It is your ethanoic acid plus ethanol, and after that it forms ethyl ethanoate. It forms ethyl ethanoate or ethyl acetate. So the reaction of ester with strong bases to form soaps. जब भी कोई रिएक्शन होती है एस्टर और स्ट्रॉन्ग बेसिस के बीच में, आफ्टर दैट इट फॉर्म्स द सोप. This is known as saponification. This is known as saponification. Acetic acid also reacts with strong bases to form sodium acetate and water. For example, this is your sodium hydroxide plus acetic acid plus sodium acetate plus water. Next is soaps and detergents. So sodium or potassium salts of the carboxylic acids is known as soap. That is sodium or potassium salts of carboxylic acid is known as soap, and they work most effectively in soap water. They work most effectively in soap water. Detergents are sulphonate or ammonium salt of the long chain of carboxylic acids, and they can work effectively on soft as well as hard water. They work effectively on soft water as well as hard water. They can work very effectively on strong hard water as well as soft water. Next is the cleansing action of soaps and detergents. So the cleansing actions of the soaps and the detergents is due to the availability of minimize the surface tension of water. That means the most important function or the cleansing action of the soaps and the detergents is due to the ability to minimize the surface tension of water, to emulsify oil or grease, and to hold them in the suspension of water. When soaps dissolve in water, when soap dissolves in water, it forms soap anions. It forms soap anions and soap cations. So the hydrophobic part of the soaps and the detergents are soluble in grease. The hydrophobic part of the soaps and the detergents, they are soluble in the grease, and hydrophilic part is soluble in water. Next is soap and Micelle formation. When dirt and grease are mixed with soap water, dirt and grease mixed with the soap water, soap molecules arrange them in tiny clusters known as micelle. The hydrophilic part sticks to the water to form outer surface of the micelle, and hydrophobic part binds to the oil and the grease. So this is the structure. Positive. So this is the soap micelle, and this is the soap micelle entraps the water molecules. So these are the soap molecules. These are the soap molecules. These are the soap molecules, and here this is the water, and this is the dirt, particles, oil or grease. These are the dirt, oil, particles or grease. So here the soap missile entraps the dirt particles. So here beta, this is all about the chapter that is the carbon and its compounds, and this is your quick reason for the examination that is to be held in November 2021, and this is the short-term revision for chapter 4 that is carbon and its compound. So this is all about this chapter. कल बेटे हम आपके साथ नए टॉपिक और नए वीडियो के साथ दोबारा से मिलेंगे. तब तक good evening to all the students who joined with us our live APS classes.